Hey, it's Kevin Lawton with the New Warehouse Podcast, bringing you a new episode today. And on today's episode, I got two guests with me. I have Steve Castle, who is the Director of Sales and Marketing at AutoQuip Corporation. And I have Chuck Cobb, who's the VP of Sales and Marketing at PFlow. And what are we going to talk about today? We're going to talk about VRCs. And if you don't know what that stands for, well, we're going to dive into that too. And we're going to explain what those are all about. And this is part of the MHI Industry Group series that we've been working on here. And VRCs fall underneath the CSS industry group. And we're going to talk a little bit about that there as well and what that kind of means. So let's get started here. And Chuck and Steve, welcome to the show. How are you both?
Great. How
Great.
are you? Thank you for inviting us.
Definitely happy to get you both on. Happy to be talking about this and diving a little bit more into this. So, I think we want to kick it off here as I teased a little bit. VRC, what is that exactly for people that are not familiar? So, Chuck, why don't you kind of tell us a little bit about what VRC stands for and what is that really?
Okay, a VRC stands for Vertical Reciprocating Conveyor.
Mm,
It's a fancy word for a freight lift or material lift, as several people
mm,
refer to them as in our industry. Um, Basically, they came about in the early '70s, and at that point they were not allowed to go straight vertical. They had to go at an incline.
mm,
And so Flow at that time, you said PFlow, it's actually Flow Industries.
okay.
Um, we kind of took it on ourselves to battle the elevator industry because the elevator industry did not want us to go straight vertical. They wanted us to go at an angle.
Mm,
And that's the reason we were going at a 15-degree angle. We fought the code and got it, and finally won in court that basically the judge said, well, if you're pregnant, you're pregnant. So if you're going up, you're going up. So
yeah.
what difference does it matter if you're going straight
Mm,
or at 15 degrees? And that's kind of the way. And then other companies joined in. AutoQuip came on board. Several of the other people that build them today. We have three basic other competitors that manufacturers that build them today.
mm.
But it was that's basically what it is. I mean, it's not, most people think conveyance is normally horizontal conveyance, not necessarily vertical. So that's how the industry basically got started.
Interesting there. Yeah, yeah. Interesting. That history too on the kind of fighting against the elevator industry actually that's pretty interesting. So I guess tell us a little bit too about because the VRC too is now like a subset of this CSS, which is conveyor and sortation systems industry group right within MHI. So tell us a little bit about I guess the tie-in there and why is there like a specific subset under that industry group for VRC?
Well, the basic reason for the subset under it is because our industry is not as large as the horizontal industry.
Mm,
We basically have five people that build VRCs, where the horizontal conveyance industry is, I don't know, Steve, pick a number, what, 100 times our size.
Right. A lot
you
more
know,
members in that group, sure.
yeah.
huh?
A lot more members in that group for sure,
A
and
lot more members in
much
that group,
different. Yep.
and dollars spent every year on horizontal conveyance versus vertical conveyance. So,
Mm,
not that we're, but anyway, that's the reason we're up underneath that group. It wasn't. We're just not a large enough group um, to, to have our own section, I guess is the way to
gotcha.
say.
Okay. All right. And that makes sense definitely. And I think, um, when you look at these VRCs, right, or these vertical reciprocating conveyors, and as you mentioned, Chuck, basically a freight elevator in a sense, right? Tell us a little bit, Steve, when you look at these from an operational perspective, what are some of the benefits of these, and where do you typically see them being installed? What type of applications, what type of operations are typically putting these in place, and for what reason?
Well, obviously, the number one application for a VRC is to move material between levels. It could be two, three, five, however many levels that the material needs to be moved to and from.
Mm.
But the primary difference between vertical reciprocating conveyors and some of the other conveyor types is that we typically have a singular platform that moves between those levels, um, and the reciprocating means that that platform moves back and forth. And there are other types of vertical conveyors that might be continuous, where you might have multiple platforms that reciprocate between multiple levels.
Mm.
Um, but the thing that's unique about the VRCs, I think, is that the code that we designed to B20.1 for VRCs, that subsection actually is designed so that you can manually load the platform. So if we have a platform where someone is pushing a cart on, or pushing a pallet jack, or
Mm.
whatever the product is that they're loading, they're manually rolling that onto the platform. So the guarding that's required for that lift is different than it is for a typical conveyor,
Mm.
where a typical conveyor may not have any physical guarding around it. The VRCs that we manufacture all have specific types of guarding and interlock gates at all the landings to keep someone from falling off an opening,
Mm.
or to keep someone from walking underneath the platform as the lift comes down. So there's some very specific guarding that's called out in the codes that we all participate in developing. Beyond that, in the I guess in the vein that we really want to focus on today in automation, the guarding that's required for that is different than the guarding that's required for a manually loaded VRC.
Mm.
Um, and in some states, they recognize the B20 code for vertical reciprocating conveyors. But if it's not manually loaded, meaning if it's fed by a conveyor at all of the landings where you don't physically walk on to load the platform,
Right.
then they don't even necessarily apply the B20 code. So there's quite a bit of difference depending on the application, what codes are required, what guarding is required,
Mm.
what controls we supply. And so there's a lot of variations depending on the application, the type of lift that we use, and the type of guarding that we provide.
Mm. Interesting. And Chuck, do you want to add anything to that?
Yeah, well, Steve hit it right, right on the head. The only other thing that I'd add is, now, and then there's the third aspect of this is when we start moving AGVs, or automated guided vehicles,
Mm.
or we're doing stuff in what they call ASRS type systems, where
Right.
it could be ASRS is kind of a little to us is a little bit broad spectrum, because most of the ARS guys have their own vertical conveyance in it, but we do a lot of working with other integrators that have the AGVs or RAF systems, or different types of these automated guided vehicle, or feeding it at multiple levels above the floor, that have no people up there at all.
Mm.
It's just these some type of conveyance up there, be it an AGV, or some people call them rafts, some people call them, just 10 or 15 different acronyms that people use for them. But so, that brings another, um, type of guarding into play, because at that point, if there's no one up there, we don't have to have pretty much any type of guarding. Whereas, even as Steve was saying, some of the states don't require any guarding other than a 3 foot, what OSHA would require,
Mm.
a 3 foot guard on each side of the entrance of the conveyor, so that people can't get their hands into the shaft way, so to speak, or to the to where the lift is actually moving up and down.
Mm. Yeah, yeah, and I think that's a pretty important thing, right? We don't want to get our hands stuck in there. That's for sure. Yeah, right. And I think, that's one of the things that guides kind of these standards in a sense is that safety, and it's important to note that for sure. And so, I mean, I think it's interesting because you talked about Chuck earlier. These have been around for quite some time, right? So I'm curious. I mean, I mean, approximately when do we see the shift? Because Steve, you mentioned in there that some of these lifts now they're a little different if they're going to be moving some of these AMRs or AGVs on them than if they were moving from like conveyor fed or otherwise. So tell us a little bit about kind of how that maybe changed the landscape of VRCs a little bit. How did that kind of change what they looked like, and maybe too, I mean, how did that change the potential like opportunities of things that you could do with AMRs or AGVs if you could, move them around to different levels and things of that nature?
Yeah, that goes back quite a few years, but
Mm.
you know, the, there are some real large distribution companies that basically develop their own AMRs for use in their distribution sites, and we worked early on with several of those companies that were developing the AMRs. And so not only were we designing the platform for the lift to handle the AMR traffic coming on and off, the AMRs themselves have different designs, where some of them are just guided by a QR code on the floor. Some of them are guided by tracks, and they just run in 2 or 4 directions specifically.
Mm.
So sometimes we'd integrate the track system onto the lift platform. Sometimes we would just design the platform to allow the space for the AMR to come on along with its load, so the platform could be sized for a larger load depending on whether it's a pallet or whether it's a big slave skid or what it is. But then once it's on there become concerns about, well, at levels 2 through 5, there's no personal access, but at level 1, there's a picking area that's close by. So when the lift comes down, we do have to guard this space. And because we know that AMR is going to be coming in and out of the lift, we have to protect that zone, because someone could physically walk around and walk into an area that they're not supposed to be. And if that occurs, then we have to bring in special controls functionality to monitor that area, either light curtains
Mm.
or a variety of scanners. And there are things that we can use. So if someone enters an area then they're not supposed to be, that we can stop the lift operation, and then also communicate the status of the AMRs themselves. Because when we're communicating through our control system with the AMR inventory management, or the warehouse management system, it's tracking the inventory, which way they're moving, and so that all the traffic of the AMRs. But we're also communicating the status of the lift. So if the lift is at level 5 and it's not being called, to another level, then we're communicating to the control system, to the AMR control system, or the WMS system, or both. And we kind of focus on being as involved in that as we can, because it makes the most use of the lift, but it also makes the best of managing traffic,
Mm.
so that we're um, moving the lift not just to the right level, but also communicating with the AMR, so that um, there isn't a loss of communication. Although the AMRs primarily operate wirelessly,
Mm.
so it can become a dangerous situation if the lift is not at a level and the AMR accidentally drives into the shaftway. It can actually drive off into a floor opening when the lift's not there.
Oh.
So communication of the controls is really critical. And then there's additional features that we can include on the lifts themselves. We've done some that have restraining devices on the platform, so when the AMR comes on, we actually lock around the opening.
Mm.
And then we also have done some projects where, when the lift is not present at that level, we have blade stops or some kind of a physical barrier, so that the AMRs, even if they received a wrong control command from the AMR control system, that we haven't created a hazard by having the lift not present at that specific levels, because again, we don't have gates like you would in a manually loaded application.
Interesting. Yeah. Yeah. And I think, obviously we don't want any AMRs falling from the sky, right? I guess in a sense. So, yeah. So,
Not a pure price ticket for sure.
yeah.
That's right.
Yeah. Yeah, I mean, that's very important, right? I mean, to have that communication and make sure that that's flowing, right? Especially because, like you said, there's no gates in that instance, and making sure that those kind of safety stops are in place too if they need to be triggered for whatever reason, and to prevent things like that from happening. So I mean, very interesting there, because I think that it's kind of, you go back to looking at an operation, and I know, was being a previous operations manager and a warehouse manager, we look for additional space in the warehouse, right? We look up, right? See, like, what else can we do with this cube, right? And how can we take advantage of the volume we already have within the existing space, and not just remaining at one level and all these different things. So as we look at that, and maybe Chuck, you want to chime in on this one here, like, you know, what does an operation typically look at, or what's like a trigger for them to say that, okay, we should start to look at these VRCs and try to implement them into our workflows to be able to either increase our space utilization, or do some other type of solution that makes sense to do that.
Well, I think this goes, a long way. This is kind of a tough one to answer, but
Mm,
we get, I know Steve and I both get calls every week from people that are, from engineering staffs that are looking to maximize their space. And everybody looks at going vertical these days because of the cost of real estate
yeah.
and the footprint that's available, especially in the Northeast. And if you're like in out the great state of Oklahoma, where Steve's company is, um, real estate is vast there. So people don't, in Texas and places like that where there's a lot of land, usually don't go up as much, except for companies that are established, that are already doing high rise buildings. And when I say high rise, to us, a 5 level VRC is a pretty high rise.
Mm,
Not that we both haven't done much taller units. Um, you know, I know we both have, but both of our companies have. But it's to me, it's always about, you get that call and somebody's look what they're looking for, and then you work with them. We don't really get the or I it's not like we run out there, and even though we promote it, it's because we've already done it.
mm,
And it's not like we're out there trying to sell to most of these distribution companies um, a new concept, because concept's been out there, and they're all, like I said, it's more about maximizing the real estate.
mm.
To me, I mean, maybe I didn't answer that correctly, but
Yeah, no. I mean, I think that's the goal at the end of the day, right? Is to maximize their real estate, as you said, and I guess maybe to go a little further in there, like, what are some of the qualifying factors that an operation would need to have to have it make sense to start to utilize some of these VRCs, or start to implement them and put them in place? I mean, what do you think about that, Steve?
Well, one of the salesman's favorite terms is "it depends," because uh,
That's all around the supply chain, I
we
say. Yeah.
yeah we like to have a solution for any problem, but I think a key trigger, if you will, um, it kind of depends on what the customer needs to do, and I've seen applications where it might not make a lot of sense to put in an automated system with conveyors or with AGVs and those types of things, just because of the the quantity of inventory that they're moving. But at the same time, for a typical VRC in a manually loaded application, the things that drive cost of ownership and maintenance and downtime is a lot related to the manual interface,
Mm.
meaning people are manually opening and closing gates and slamming things and putting things in the wrong place, and all those things contribute to the cost of ownership for the VRC.
Mm.
Whereas it might not take a complex automated system to be able to eradicate or eliminate that cost, because if you just had a single queue station where a pallet was brought to that queue station and dropped, and the VRC automatically loaded it, the operator doesn't have to stand there and wait for the lift to arrive and manually load it and push a button to send it. He basically brings the product to that queue station and drops it. It could be a forklift, it could be a mobile robot.
Mm.
Any of those things can use a single queue station to load the VRC, and we can, in that way, we can remove the person from the process of loading and operating the lift, which in my experience reduces the cost. Also makes it more efficient because the person isn't, standing there. In some of these buildings, we've even had to put in control time, control timers, so that you didn't have an operator at one level standing there holding the button. So when the lift arrived at another level, the gate unlocked, but
Mm.
before they could open the gate, the lift left and went on to another level because someone at the other level was holding the button to call it
Ah,
to their level.
yeah.
So we can do some things with controls to kind of avoid that situation. But at the same time, a better solution would be to create a very small automated loading queue station at those levels so that the operator isn't constantly fighting over the use of the lift. So
Mm.
I think those types of situations are where it would definitely trigger considering a more automated approach.
Mm.
And it's all about volume. I
Yep.
mean, it's all about volume.
Yeah.
You know, I think the one thing that, and Steve, you're absolutely correct, everything you said, but the one thing that, just to expand on it, is the volume that can be done by that one queue station type operation. You can handle, let's say, with no speed increases or anything, 30 pallets an hour, between a 20, 30 to 40 pallets an hour, um, in an automated situation, where if you were doing it manually, you might get 15.
Mm. Interesting.
So it's, because all you're doing is bringing it, as Steve said, you're bringing it there, you're dropping it off. The guy goes and gets another one before he gets back.
Yeah, yeah, and I think that's an ideal scenario there because you got, like you said, Steve, you get the one guy's holding it, and then it's going past the other guy, right? And at all that time, somebody's waiting there, right, to have to do this load, right? So, which is just wasted time essentially, where they could be doing more work or whatever the
And,
case may be. So,
and,
yeah,
then,
I think
and
that's
then
a really
you can
thing
even
to.
expand on that. I mean, like Steve said, one, but most of our customers, and I think Steve would agree with me, um, they're going to look at 3 or 4 positions at each level where they've got a little bit of what we call a Q factor, accumulation factor.
Mm.
And, we have many customers that'll put, have 20 zones at each level, just so they have that accumulation, so that, you know, one shift may quit earlier than, and they want to have that accumulation. So during shift change or whatever, they don't have a big lag for people, you know, and that's
Mm.
where, again, like I say, it's all about volume. I talk to customers all the time, and that's one of my key things is, what are you trying to accomplish? How many are you trying to get from one floor to the other? That's the big thing. And that's kind of where we go from, or I think Steve will agree with me. Once you know that volume requirement, it makes it a whole lot easier to figure out the rest of the puzzle.
Yeah, yeah, absolutely, and I think that makes sense on the volume and the throughput side too, of like how much you're going to be moving through there to kind of figure out the
Yeah.
right size, right, and how you're going to put the solution together to make sure that not only it's going to accommodate you now, but accommodate you hopefully into the future a little bit as well, there too. So I'm curious. I mean, do you see where a lot of these VRCs are being implemented in like a brownfield environment, like existing buildings where they're putting in new types of solutions or trying to maximize that space, like we talked about before? Do you see more being included into new, like greenfield, highly automated buildings that are coming online?
I think it's
Well,
both.
yeah,
Go ahead, but I
well,
think it's both. They're building new warehouses constantly,
Yeah.
um, but I've also seen we've had a few recurring customers where might have an existing warehouse that was all manually stocked,
Mm,
multiple racks, all manually stocked with forklifts. And because of maintenance and hazards of high level storage and the density, they've moved to they basically tore out all their manual rack storage positions, and they've installed 5 levels of a resin deck or some kind of uh, a mezzanine, a rack supported mezzanine that might have 5 levels in it, and with that they can basically, if there's consistency in the product as far as the storage space, but we've also set it up so that at levels 2, 3, and 4 they can store product that's 7 feet tall, but at levels 4 and 5 they can only store products that are 60 or 48.
mm,
So the additional things that we do whenever the product is brought onto the lift by the AMR is we measure the height of the lift or the height of the load with a series of photo eyes at different heights and say, okay, if the load is below this height, then we can store it at this level. If it's above this height, then it can only be stored at this level. So we provide feedback through the control system to measure the load where it can be stored, and then to basically limit what level the lift goes to based on what we know. So it's kind of a double check. We know the load can only go to a certain level because of the height, but we give feedback to the AMR controls or the WMS system as far as monitoring the load itself and where it's going to be delivered.
interesting, interesting. Chuck, you had something you want to add?
no, I'm good. He covered it.
Okay. All right. Yeah, so I think it's very interesting, and I think that's great too. I mean, the technology being able to recognize that through a photo eye, right, the height level, and making sure that it's not getting dropped off at the wrong level where it can't fit, essentially, right? And that's that could be a headache, I'm sure, if that would happen. So very interesting there, and interesting to learn about these VRCs and kind of how they're being implemented from where they are from like a manual loading perspective versus the automated and AGV AMR integrations that can happen there as well. Now, if we look to kind of the future of VRCs, I mean, how do you see kind of VRCs evolving? What more can be done with them, or what other types of technologies do you think that they're going to start to get integrated with too, as well as our industry continues to evolve?
Well, I think one of the things that we're going to see more, and when we've started doing some of it, but and I'm sure Steve's company has too. We've actually had quite a few loaded with robots. And when I say robots, I'm talking about the stationary robot that picks and sets and actually builds the pallet right on the lift, um, rather than it being transported by an AGV or by a conveyor. Um, uh, so, I mean, I don't know. That's a tough question because
Mm,
I don't know. We kind of, or at least I feel that every year some new request in technology comes out. But I guess the biggest thing right now is that I see is safety,
mm,
and that, as Steve said, it's control based. A lot, we're getting more and more requests from our larger customers about. Um, yeah, I would have never dreamed that some of the requests that we get at this point from a couple of our customers about the amount
yeah.
of controls that we have to meet, and the only thing that worries me is the cost factor. Um, but it hasn't seemed to slow it down any, because everybody is so safety conscious these days, and not that they should not be. I mean, I totally agree we need to be safe, but I mean, it's just the amount of safety that's being built into these things is a little bit overwhelming at times. So it's a constant challenge from year to year, I should say. And I think Steve could back me up on that one.
It's definitely evolving, and as safety becomes more and more of a center focus. I mean, our VRC committee is reviewing some code changes right now that will, in the near future, implement a requirement for risk assessments, and it's something that a lot of customers are asking for. It's becoming more and more common, and then that's not just an understanding of the lift and what surrounds the lift in terms of hazards, but also um, the application. And some of that requires a lot of customer involvement in terms of the processes and the areas that they have access to the lift, and all the guarding that we talked about earlier becomes a lot more complicated. But also, whenever you do a risk assessment, it's not just having a document that you deliver. That document drives you to look at every risk that's associated with the application, and then design your controls architecture to support that through a variety of procedures that I can't even explain in great detail, but I do know that, like Chuck said, it will affect the cost, and it will affect the complexity and the redundancy of your control circuits. And it also will affect the functionality, because no longer can you just walk up to a lift and push a button to call it to another level. Every time, if it's a manually loaded lift, every time you open and close the gate, there has to be a redundancy in circuitry so that it resets the safety circuit. And that's most commonly done by hitting another push button to reset the safety circuit before you can actually operate the lift. So it affects the function. So there are a lot of things that they're trade-offs to additional safety. It may be at the cost of a little bit less convenience, but it definitely adds cost to the control system. And our controls division, OSCO Controls, which is a subsidiary of AutoQuip, they've really helped lead us through this process in a way that it's been really interesting how it's evolved over the last few years. And it's right in time, because the B20 code is changing from, it used to use the term a risk assessment should be done. Now it says it shall be done. So I think as they enforce that, and that's actually driven more by not the vertical conveyor part of the conveyor group, but more from the horizontal conveyor group. And so it's going to affect all of us over time, but it's definitely
Absolutely.
requiring new technology and new ways of looking at a lot of problems that we've solved in the past mechanically, where some of these we're having to solve electronically.
Interesting.
I agree wholeheartedly, and that's not it is more difficult to deal with. I, I used to like to figure out the mechanical problems. The electrical problems are a lot harder.
Yeah.
And as Steve said, we as a group, but our director of engineering sits on that B20.1 code committee, and he keeps us, keeps the industry abreast of what's being required, and so it's, but that is one of the big challenges.
Yeah.
Moving forward, but it's going to continue that way. It's not going to. I think that in the future we will see more automation. I just don't know exactly what the next step in automation. I don't think we've fully got to the point where AGVs and AMRs are, and robotic arms are totally integrated yet.
Yeah.
Um, so I think that we probably, and this is an old guy guess, but as I'm tailing out my career, I think we probably got about another 5 years before we see a lot more requirements for it. Now that's just a guess. That's not anything that I've read or anything else. I'm just going by my experience in the industry after 30 years about how things kind of cycle through. But I'll call it an educated guess.
Got it.
Yeah, I think over time we see kind of waves in automation. This kind of someone starts doing this for a while, but I think it has to prove itself out. And I've seen, I've heard of people that go in and do a wholesale changeover to automation and end up backing up some and changing some things. And
Correct.
I think it's great to prove things out before you do them wholesale across your whole company network. Um, but I think it's if our lift designs are haven't changed dramatically, but there are features that we have added and created and developed just specifically for AMRs because an AMR when it's pulling off at a level isn't as critical, or it's a lot more critical than a pallet jack or someone that's loading a box on manually. So the alignment of the platform with the landing level or the tracks that we're aligning with becomes a lot more critical. And so the normal carriage float that we designed for can't occur. So we're even adding a variety of mechanical locking systems to lock the platform exactly at a specific position every time it comes to a stop. And the controls it takes to do that are far more complex. So we're using a lot of redundant feedback, not just an encoder on the motor to operate the varying speed of the motor and the position of the lift, but the platform itself having a secondary feedback and mechanical locking to align more accurately with the floors. And those are things that were developed specifically for AGVs and AMR type applications, where in the past with like roller conveyor and things like that, we've always handled, it wasn't necessary, but it is necessary for these types of interfaces.
Yeah, where a half inch used to be okay, now it's a 16th or an eighth.
That's right.
I mean, they want an eighth or a 16th. A half inch is, oh no, we can't handle that. Oh
That's
no,
right.
that won't work.
Yeah. I mean, I think it's a very interesting perspective because it is the more technology comes into the industry, like the more precision there needs to be, right? The more electronics, as you mentioned, are getting involved, and kind of the more complex everything around that technology becomes as well. That needs to support it and integrate with it and be a part of that. So very interesting learning about the VRCs today from both of you guys, and also learning about kind of the development and evolution of them, and also now looking towards the future and what's happening as other technologies are starting to surround them and become integrated with them and a part of them as well. So I really appreciate you both joining me on the show today and talking about this topic. If people are interested in learning more about VRCs and I guess getting in touch with the industry group itself, what's the best way to go about doing that?
Well, the industry group, they can look at the MHI website that would direct them to the manufacturers that are involved in the MHI participating in the code development and the standards. And we all have links on the MHI website, either to the PFlow or to AutoQuip, and all the other manufacturers are listed there as well. And I appreciate you having us on. I'm sorry that we couldn't have held this in person in Marco Island, Florida, but obviously we had some weather-related challenges with that. But it's been a pleasure to be on the
Absolutely.
podcast with you.
Yeah. Appreciate you both coming on. And yes, we definitely wish that we were by the beach when we were doing this for sure. But we will definitely put all that information about VRC and where to find out more information, how to get connected with Steve and Chuck at thenewwarehouse.com, and also in the podcast show notes and video notes as well. So thank you once again, Steve and Chuck, for joining me on the show today. Hey guys, thank you so much for tuning into today's video here on our YouTube channel, The New Warehouse Podcast, and I appreciate you tuning in. If you liked what you saw, make sure you subscribe to our channel, and if you like this video in particular, make sure you like it as well. And if you want to get this great t-shirt that you see in the video behind me, Warehouses Are Sexy, head to warehousesAreSexy.com and get your own.